Okay, just a couple more little things to finish up. I know I'll be re-saying this again when I see you because I know it's hard to get your head wrapped around. But this is our equation, okay? So EK max equals HF minus WO. EK max is the kinetic energy of the electron, okay? And yes, kinetic energy, 1/2 mv squared. Okay, so this is the kinetic energy of the electron. HF is the energy of the photons. It's the EP that Maxwell Planck came up with. Remember, EP was equal to HF. So we just write HF in there instead of EP. And then WO, which is the y-intercept of the graph. WO is the energy that the metal needs before it'll release the electron. It's also known as the work function. And earlier we said the work function was equal to HF because it is just, WO is just like an energy, but with a special frequency, so it's equal to HFO. So each of these is an energy. This is the energy that's coming in. This is the energy that the radiation that's striking the photosensitive metal. This is the energy that the metal needs before it's willing to give up an electron. So if HF is not bigger than or at least equal to WO, right? So if HF needs to be greater than or equal to WO, well, remember WO is HFO. The H's are constant. So we're saying the frequency of the light coming in has to be equal to or bigger than FO for this equation to work. Okay, so if you're ever doing a calculation and you get a negative on this side, it means the frequency is less than the threshold frequency and nothing's going to be given off. Okay, so the work function is like the deposit that you need to give the metal for taking the electron away. So if you have enough money to give that deposit, then you'll be able to take the electron away and give it some traveling energy, right? So what's left over after you pay the deposit to the metal for the electron, what's left over in this HF is given to the electron to travel with. Sometimes I use the analogy of, imagine that you're stuck in your house, your parents won't let you go anywhere, you have a miserable life, but you have a rich aunt, and the rich aunt says, well, how about if I send you money so you can move out? But your parents, so this is the HF they're going to send you, but your parents say, well, you need to give us some money to let them go. So they're setting a work function. They're setting a minimum amount of money that you have to give that they will take before they'll give you your freedom. Okay, so I don't know, maybe that minimum amount is like $100 because you're worth a lot to them. So if your aunt only sends 80, your parents are like, too bad, you don't get to leave. But if your aunt sends 120, then they take 100, and the 20 left over is yours so that you can call a cab and get out of there. Okay? So this is the amount of energy coming in. This is what the metal takes before it'll give up the electron. And then anything that's left over, anything that's excess from this right-hand side becomes the traveling energy of the electron. Okay, so what happens then if I increase the frequency here, it means your aunt is sending in more money. There's more energy in this packet. And so it doesn't change the number of electrons that get released. That's why that graph was, when we did frequency with number of electrons, it doesn't change. But what it does change is the money left over that gets to be given, or the energy left over that gets to be given to the electron. So increasing the F increases the energy of the photon coming in. The work function doesn't change, so the electron ends up with more energy. If you change the intensity of the light, you're not having any effect on the EP. The EP, the energy of the photon, is determined by its frequency. What you're doing when you change the intensity is you're sending in more packets at a given time, which means more electrons can be freed. So if your aunt sends 2 packets, then it means you and your kid brother can both get out of there. Okay? All right. So now the one other thing that I probably should say, and then we'll call it a day, and that is, we know from grade 11 physics that energy is measured in joules. But when we're talking about electrons, a joule is a huge unit. Okay, that's like trying to measure the width of a hair with a meter stick. A joule is just too large of a unit to use when dealing with atoms. And so instead we use a unit that's called an electron volt. And it's written as all one word, and its symbol is E with a capital V. Okay? 1 electron volt is the energy of one electron when it's accelerated across a potential difference of 1 volt. Okay, so remember our equation, V is equal to W over Q. And remember that W can also be written as a E, so E over Q. Okay, so energy is equal to then QV. So an electron volt is the energy of one electron. So 1 electron would be 1.602 times 10 to the negative 19 coulombs. The energy of 1 electron that is accelerated across a potential difference of 1 volt. So this is what we're going to call 1 electron volt. So 1 electron volt is equal to 1.602 times 10 to the negative 19, and a coulomb times a volt is a joule. So 1 electron volt is equal to 1.602 times 10 to the negative 19 joules. So if I had an EP or a WO or an EK max of something like 3.204 times 10 to the negative 19 joules, and I said how many electron volts is that, you would divide it by 1.602 times 10 to the negative 19 joules per electron volt, and you would end up getting 2 electron volts. Or if I said to you the WO is 3 electron volts, how many joules is that? You would multiply it by 1.602 times 10 to the negative 19 joules per electron volt, and then you would end up getting, what is that, 4.8? 4.806 times 10 to the negative 19 joules. So the conversion factor is 1.602 times 10 to the negative 19 joules per electron volt. Okay, and then you divide if you're going from joules to electron volts, or multiply if you're going from electron volts to joules. But I think if you just stop and think about it and use common sense, you'll remember that. Okay, so in lots of questions, it'll give you a mix of joules and electron volts, and so you will need to convert one way or the other, or both. Okay, so what are our equations? Well, let's list them. So I'll see if I can get them all. So we have the stopping potential is equal to, whoops, not that, is equal to, okay, scratch that, try this again. The stopping potential is equal to EK max over Q. We have WO, the work function, is equal to HFO. We have EP is equal to HF. Oh yeah, we have C is equal to F lambda. Don't forget that one. We have EK max is equal to HF minus WO. And a little while ago I had said, like, you know, they don't write this as EP, they write it as HF. And they do because the slope of the line is the H, right? And so they leave it as HF so you can see that. What other ones do we have? HF. I'm looking through to see if I missed any. And then, of course, what I just said, 1 electron volt, it's not an equation, but it's the conversion factor. 1.602 to the negative 19 joules. Okay? So if it gives you the work function, like you just figure out which one you're going to use. Oh, and of course, you know that EK max is kinetic energy, so it's going to be 1/2 mv squared. I think that's all of them. Okay, so now it's probably time to do a couple of questions to practice a few of them, but just a few.